Okay, solving of logarithmic equations. Ready, go. Number one, we've got same base. So we're basically just going to do 3 to the on both sides and cancel. And we're left with 3x minus 11 equals 25 minus x. Seems easy enough. Solve from here. 4x equals 36. X equals 9. And then we have to check it, plug it back in. 3 times 9 is 27, minus 1 is 16, 25 minus 9 is 16. It's the same thing on both sides. Okay, we're good. Do the same thing over here. 4n minus 7 equals negative 3n. 7n equals 7n equals 1. Now hold on, if we plug in, we end up with 4 minus 7 is negative 3. Negative 3 times 1 is negative 3. That's going to give us negatives on the inside. That is no good. We cannot plug a negative into a logarithm. Not happening. Not going to do it. All right, let's look at number 4. 2 times log m of log 36. Let's bring this 2 inside using our log properties and say log of m squared equals log of 36. And now we'll just do 10 to the on both sides and cancel out the logs, and we get m squared equals 36. That would suggest that m is equal to plus or minus 6, but we can plug in a positive 6. We cannot plug in a minus 6, so it's m equals 6 only. So that's the key thing, is we have to make sure that the number we plug in does not result in a negative feeding through the logarithm. All right, for number 3, we're going to do the same thing as before, but we got to do one step first. Just like in number 4, I used a log property. We're going to use a log property right here. And we're going to say this is log base 2 of 3 times 2y minus 1. That's just using the product property. All right, and then we do 2 to the on both sides. We get 75 is equal to the inside of this, which I'm going to distribute while I'm at it, 6y minus 3. So 6y equals 78, y equals 13. All right, no issue plugging in a number to 75, no issue plugging a number into 3 because there's nothing to plug in. If we put a 13 in for the third expression, we get log of 25. That's fine. So yes, we're good with that. All right, number 5. This is log 4 of 108 over 9 equals the same thing. So 108 over 9 is equal to 12. So when we do 4 to the on both sides and cancel out the logs, we're going to get 12 equals 7a minus 9. So 7a equals 21. Therefore, a equals 3. If I plug in a 3, 21 minus 9 is 12. Yup, we're good. All right, number 6. We're going to apply a log property on each side. We're going to bring the power inside here, the coefficient as a power, and we're going to use the sum to product property here. So this is log base 5 of 64 to the 1/3 power is equal to log base 5 of 8 times p. And now we'll simplify by doing 5 to the on both sides. Cube root of 64 is 4. The other one's just 8p. That seems to suggest that p is 1/2. There's no issue putting a 1/2 there. All right. Do 10 to the on both sides to cancel out the logs. W squared plus 21 is equal to 10w. This canceling out the logs on both sides thing really only works, by the way, if it is the same base. It has been so far, and I don't think that's going to change. This is a quadratic. To solve a quadratic, we bring everything to one side and we try to factor. So w minus 7, w minus 3. So at a glance, it would appear that w could equal 3 or 7. Can it? If we put a 3 here, we get a positive number and a positive number. If we plug in a 7, we get a positive and a positive. So yep, they're both good. Both these answers are valid. We have two solutions. All right, number 8. Going to bring the sum together as a single logarithm. 2x times x minus 7 equals the same thing. And now we'll do 2 to the on both sides. So 2x squared minus 14x is equal to 4x. This is a quadratic, so I'm going to bring everything to one side. 2x squared minus 18x equals 0. Factor out a 2x. Whoop, what's going on here? Get back here. 2x times x minus 9 equals 0. Seemingly, x equals 0 or 9. If we plug in a 9, 18 plus 2 equals 36. Okay, those are all valid numbers to put in a logarithm. But for 0, we get log of 0 and log of 0. You can't do 0. You can't do negatives, but you also can't do 0. It has to be a positive number. So x equals 9 only. All right, so in general, let's talk about our procedure here. When we have this situation, step 1 is get a log on both sides. I guess I should say get a single log on both sides. To do that, you may need to use properties. Those log properties, those lovely, wonderful log properties that you love and adore so very, very much. Then you're going to exponentiate both sides, provided that the logs are the same base. Which they were in all of these other ones. If they aren't, use change of base property. Use change of base rule, which hopefully you won't have to deal with, but if you do, it's not the end of the world. It's just an extra step and it's obnoxious. So this basically cancels out the logs on each side. And then step 3, solve from there. Step 4, test the solutions. You must be inputting a positive number into the logarithm. All right, how's that look? It's not that great. Okay. Change a couple of these so at least it looks a little prettier, because we got to make it pretty. How about now? Okay. There we go. That works a little bit better. So there is your procedure. So go with this right here as your general guideline for here's how you done do it. Save, and now we're going to clear. And we're going to scroll on down and look at page number 2. And we're going to use these same procedures to solve the questions on this page. So first step, is it a log on both sides? Well, no, because we got 2 logs over here. So let's rectify that by making it a single log using log properties. This is subtraction, so we need to use a division inside. Okay, and the right side leaves alone. Now we have log base 4 and log base 4, so we do 4 to the on both sides, and that kills off the log. So we have this stuff is equal to 8, but this stuff I'm going to simplify to m squared minus 7m. And now we got a quadratic to solve. And we factor. Seemingly, we have m equals 8 or negative 1. All right, if we plug in an 8, 2 times 8 to the third minus 14 times 8 squared. Well, we'd have to check on the calculator, but I'm pretty sure that's positive. 2 times 8 is also okay. So 8 is fine. But let's plug in a negative 1 now. So this is negative 2 minus 14, that looks like it's negative. And then log base 4 of 2 times negative 1, that's also negative. We can't have that. It's 8 only. All right, number 2. We got this 2 in here. Let's use our properties and bring it in as a power. Log of x minus 3 squared is equal to log of 25. All right, we will remove the logs from both sides. X minus 3 squared equals 25. Now you can either multiply that out and solve it as a quadratic, or you can just square root both sides right now. X minus 3 is equal to plus or minus 5. So x is either equal to 5 plus 3 or negative 5 plus 3. But then we test our answers. If we put in an 8, 8 minus 3 is 5, 5 squared, that works. If we put in a negative 2 here, negative 2 minus 3 is negative 5 squared is positive 25, that also works. So even though this is a negative number, it's a valid answer. Looks weird, but it works. Except it doesn't. Sorry, let's go back to our original. Let's go back to our original. If we put in a negative 2 up here, this becomes just straight up log of negative 5, and that is no good. So I stand corrected. This is also 8 only. And we're going to go through all these other ones the same way. Now, the number 11, we don't have a log here. We're still going to do 3 to the on both sides. It's just when we do 3 to the now, this cancels the log, but this becomes a number. Before, when we were doing this, what we were basically doing is we were saying, oh, log of whatever equals log of 25. Well, let's do 10 to the on both sides, and then it cancels the log. And so this dropped down and this dropped down. But now the right side isn't a log. Well, that's okay. We can still just exponentiate both sides. So we do 3 to the 3 because it's the base of the log. And we get 2x minus 7 is equal to 3 to the 4th, which is 81. So 2x equals 88 and x equals 44. All right, so to simplify what we said before, if one side has no log, just exponentiate both sides, and the one side will be in exponential form. No big deal. So, all right, let's isolate this logarithm first of all, get it by itself. So log of stuff is equal to 3. All right, it's log base 8, so we're going to do 8 to the on both sides. And so the right side is 8 to the 3rd. You might want to get a calculator, but I'm pretty sure it's 512. And the left side is the guts of the logarithm, 28k minus 20. I probably did that too fast. Let me back up and let me do that slower. All right, so first of all, we want log equals normal number. We're going to do minus 15 to both sides. That part probably made complete sense. Let me write this out. 28k minus 20. Ignore my garbage handwriting with the mouse. And now, to get rid of the log base 8, we're going to do 8 to the on both sides. This will cancel that. This drops down. And the result now is 28k minus 20 is equal to 8 to the 3rd, which is 512. So we'll add 20 to both sides. And now we got to divide by 28. K is equal to whatever the heck that is. We grab a calculator. I don't do that one in my head. Looks like 19, but I don't know. 19, maybe, perhaps, I think. I don't know. I don't know my 28 times table. So 13 We'll do 9 to the on both sides, just like before. We're going to say, oh, well, we need to get rid of this log, so 9 to the on both sides, which means we do 9 to the 1/2. So this is 15 minus 4n is equal to 9 to the 1/2, or square root of 9, so that's 3. Negative 4n is equal to negative 12, n equals 3. All right, I didn't test on these other ones, but they do work. 44 is okay. Whatever number that is going to be okay. 3 here, 15 minus 12. Yeah, that looks like it's okay. We're good. 14. Make it a single log first. Log base 2 of 4c minus 9 equals 5. And now we will exponentiate both sides. So we're going to do 2 to the on both sides. And that means that we have the guts of the logarithm dropping down, which I'm going to distribute while I'm at it, is equal to 2 to the 5th power, which is 32. 4c equals 68. C equals 17. Sanity check, can we plug in a 17 here? 17 minus 9 is 8. Yes, yes we can. All right, in the last two, we are desperately low on space, but maybe we can make it work. We could bring the 2 in on the inside, but even easier, let's just divide by 2. Log base 4 of k equals 2. And then we will do 4 to the on both sides, cancel. And we get k is equal to 4 squared. So in other words, k is equal to 16. And 16 is very clearly a number we can put in there, so we're good. All right, 16. We'll do exactly as before, wrong green color. 8 to the on both sides, wacha. And now we got p squared plus 15 is equal to 8 squared. So p squared is equal to 64 minus 15 is 49. P is equal to plus or minus 7. If I put in a 7 here, I get a positive. If I put in a negative 7 here, I get a positive. Unlike back in number 10, where I had to retract my response, in this case, the negative does work. So both of these are valid, plus and minus 7. So there we go. There's a rundown of solving logarithmic equations. So use the steps that I listed at the beginning, and in these later ones where it's not a log on one side, just do exponentials on both sides like you would before, or write it in exponential form if you remember how to do that from the beginning of the chapter, because your teacher might have taught it a slightly different way, where you put the thing over here and bring this over there and put that over there and hocus pocus, there you go. If you remember that instead, hey, do it that way. But write it in exponential form, basically, once you have a single log. And that's it. So best of luck.